Okay, we've done a lot with equations. We need to talk a little bit about linear inequalities. Okay, something other than an equal sign is an inequality. So a greater than, a less than, a greater than or equal, less than or equal. If we just want to talk about all the numbers less than 3, well, if you think about the number line, what's less than 3? Of course, the integers, we think of 2, 1, 0, and all the negatives, but of course, all those little numbers in between the integers count as well. But numbers less than 3 go all the way back to what we call negative infinity, which is like a figure 8 on its side. If I wanted to represent all those numbers, this is called interval notation. I'm starting at negative infinity and I'm going up to, oops, excuse me, that should not be a square bracket, that should be a parentheses, all the way up to a 3. Infinities always get a parentheses. The number will get either a parenthesis or a bracket depending on whether or not that number is included. If I had said less than or equal to 3, now it's going to get the square bracket because I'll tell you what, I am losing it, man. Now it's going to get the square bracket because the square bracket means it's included. Okay, so that's how I would show all numbers less than or equal to 3. All numbers greater than or equal to -1. That means I'm going to start down here at -1, including -1, and I'm going to go up to positive infinity. How would I show all numbers that are greater than -1 and less than or equal to 3? Well, all numbers would say, okay, I'm going to start down here at -1. I'm going to go up to +3, and I'm going to include +3. Now, we just may be asked to report the integers that fall into this category. So we're not going to worry about all numbers, just the integers. Well, -1 would not be included because it's not, x is strictly greater than -1. So -1 would not be included. But what are the integers between -1 and 3? You got 0, 1, 2, and 3. So -1 would not be included. 0, 1, 2, and 3 would be included. So if I was just going to list a set of numbers, we use these curly Q braces, and we just put the numbers in there separated by commas. That's how I would list these numbers here. All into integers now, if the problem said integers. Okay, so not -1, it doesn't make the cut because x has to be greater than -1, but it's less than or equal to 3. So that's how I would show that. All right, when we're solving inequality problems, it's very similar to equations. We just have to report the number a little differently because the number is now not a single number anymore. When you're solving a linear equation, there's just one answer unless we had that special case where there was no solution or an infinite number of solutions. But if I just have something like this, x plus 3 is less than 8, I'm going to solve it just like an equation. And I'm going to say x is less than 5. Okay, how do I write all those numbers less than 5? That's where we go to this, what we call interval notation. Well, less than 5 would be all numbers from negative infinity up to the number 5, but not including the number 5. Okay, the algebra is really the same. What about this one? Okay, this requires a little more work. I've got x's on both sides. I've got constants on both sides. So I'll work my magic here. Okay, this is hopefully pretty easy. It's already 1x, so that makes it easy. 1x is greater than or equal to -5. How do I show all those numbers? Well, -5 is included because it's greater than or equal all the way up to infinity. And we slap a parentheses around the infinity. Okay, so we just have a range of solutions when we're talking about inequalities. Okay, otherwise it's the same techniques to solve an inequality as it is to solve an equation. There's one little extra thing we might have to worry about, otherwise no problem. Fractional coefficient, no big deal. We multiply by the old reciprocal, right? Which just means multiply by 3. X is less than 15. Negative infinity all the way up to 15 and not including 15. Okay. Here's where we got to watch out. What if I had this problem? if I divide through or multiply through an inequality by a negative number, and I'm about to divide through by a -3, I have to take the inequality symbol and do the old switcheroo on it. It was a less than, now it's a greater than. Okay, so that's the only caveat with these inequalities. I'm going to switch the direction of the inequality only if I divide through or multiply through by a negative number. Now I've got x is greater than -7. How do I write that? -7 all the way up to infinity, -7. I did it again, I'm sorry. -7 is not included because it's strictly greater than, so they're both parentheses, no brackets. Okay. That's the only thing. So you might have to switch the inequality, the old switcheroo on the inequality. Let me just do this one here. And let me give myself a little more room. 7x plus 15 is greater than or equal to 13x plus 51. If I subtract 13x from both sides, I'm going to get a -6x plus 15 is greater than or equal to 51. And then I'm going to subtract 15 from both sides. -6x is greater than or equal to 36. Divide by -6. Divide, change the inequality, do the old switcheroo on the inequality. X is less than or equal to -6. Less than means all numbers from -infinity up to -6, including -6, so it gets a square bracket. Okay. Inequalities. That's really it to inequalities. Sometimes you might get a compound inequality. You might get something like this. Again, let me get a fresh piece of paper. What if we have, what do we have? -8 is less than or equal to x plus 2 is less than or equal to 10. You might have something like this, called a compound inequality. So it's like two problems in one. I'm going to solve them kind of simultaneously. I'm going to subtract 2 from here, which means I'm going to subtract it from here, and I'm going to subtract it from here. I'm working both ways. Well, what do I get here? A -10 is less than or equal to x is less than or equal to 8. Okay, how do I report that answer? All numbers between -10 and +8, including -10 and +8. Okay, would be that. How would I list them if it was just integers? Again, these solutions include all numbers, not just integers. But if it said list the integers, that fall into this criteria, well, what would it be? Curly cube braces, it would be -10. Oh boy, I gave myself some work here. -9, -8, -7, -6, -5, -4. -3, -2, -1, 0, comma 1, comma boy, oh boy, 2, 3, 4, 5, 6, 7, 8. Okay, those are all the integers between -10 and +8, including the -10 and +8. Watch out for that. I remember a problem on one of the exams that it asked a question like this, except I think one of them was maybe not an or equal, so maybe something like this. 4 is less than x is less than or equal to 7, something like that. List the integers that fall into this category. Well, 4 does not fall into that category. So it'd be 5, 6, and 7. Okay, so watch out for something like that. But otherwise, inequalities are really very similar to equations. Okay, so this is another kind of shorter video. The last one was short, and then we had a long one prior to that. So I guess that makes up for it. We're going to talk about systems of equations in the next video, systems of linear equations, and then we'll move on to some other types of equations, quadratic equations, and other more complicated equations.